In this lecture, I'll give you an overview of performance in ONTAP storage systems. The most commonly used performance metrics for monitoring and evaluating performance of storage are IOPS, throughput, and latency. The first one, IOPS, that stands for Input-Output Operations per Second. And this measures how many requests can be managed by the system in a second. It's most useful to use this as your metric where I/O requests are random as opposed to sequential. So the blocks are accessed from random locations on the disk. They're also small and from multiple sources. The next one that we have is throughput. And throughput is very similar to IOPS, but it measures how much data can be managed in 1 second. So it takes size into account. Throughput is measured in megabytes per second, and it's most useful where the I/O requests are sequential, where the blocks are accessed from a contiguous area of the disk, where they're large, and from one source. So if I just go back to IOPS, you can see that this is measuring how many requests are managed in 1 second without giving an indication of the size of the requests in the number reported. But obviously, the larger the requests, the smaller the amount of IOPS you'll get will be. So this is most useful where the I/O requests are small and the size is not so important. Where the requests are large, we do want to take that into account, so throughput is the more relevant metric then. Okay, so that was IOPS and throughput. The last really important metric that we have is latency. Latency measures how long data processing takes. So the client sends in a read or a write request to the storage system. How long does it take for the storage system to process that request and also acknowledge it? And latency is measured in milliseconds, or with modern systems now in microseconds. Okay, so those are our 3 main performance metrics. Another thing that we need to consider is the characteristics of the actual workload or application that is using the storage. And different workloads can and will have different characteristics. For example, the mix between reads and writes. You might have one workload which is 80% reads and 20% writes, and another workload which is the other way around, 20% reads and 80% writes. Obviously, that's going to have an effect on the performance because the storage system is able to process reads more quickly than it can process writes. Other characteristics to consider about the workload is the mix between random and sequential requests. Again, you might have one workload which is mostly random requests and another one which is mostly sequential requests. The storage system can handle sequential requests much quicker than it can random, so that's also going to cause a big difference in the meaning of your metrics as well. And the last one is the block size used by that particular workload. So because of this, you're going to see different performance for different workloads because those workloads have got different characteristics. You're going to see better performance for a workload that is mostly read requests than for a workload which is mostly write requests, for example. So the same storage system, exactly the same hardware, will achieve different performance metrics for different workloads. And these will be different than the benchmark metrics reported by the vendor. So when a vendor comes out with a new storage system, they will release figures about the achievable IOPS, throughput, and latency. But obviously, all the vendors will make their storage system look as good as possible. So they will do that using a workload, which is really going to highlight the performance of their system. For your actual workload that you're going to be using in your real-world environment, you can't really expect to get those same performance results unless you're using a workload that has got exactly the same characteristics. So when you are going to be provisioning a storage system, you should size it and also preferably test it beforehand with a proof of concept to meet the requirements of the workload or workloads that it is going to be servicing. Okay, there are some commonly used performance measuring tools from NetApp. You can use the command line. The main command that you will use at the command line is the statistics command. You can also use System Manager as well. As we've been going through the course, you'll have noticed that on a lot of pages, such as the volumes page, it does report those performance metrics right there in the GUI. You can also use Active IQ. By default, your storage system is going to be sending information to NetApp on a weekly basis, including performance reports, and you can view those reports via Active IQ. To get more detailed analysis, you can use On-Command Performance Manager, which is part of the On-Command Unified Manager suite. So as well as just giving you like the raw metrics, you can also do things in Performance Manager, such as setting thresholds and getting an alert if the system goes over that threshold. Performance Manager is used in a purely NetApp environment. If you've got a heterogeneous storage environments, so storage systems from different vendors, and you want to be able to monitor them all from a single pane of glass, you can use On-Command Insight for that. On-Command Insight also has performance reports. Another tool is PerfStat. This is a tool that you run on your system that will gather lots of information, including performance details. And NetApp also have other tools available just to the internal staff and partners. But because those tools are available, if you are working with NetApp or one of their partners, they will be able to do more detailed analysis of performance for you. Okay, next thing to talk about is utilization and headroom. So this is for an example workload here on an example storage system. And you can see that for this particular workload, here is the acceptable latency is at this amount here. And this is on an example live system. The workload is running here, and we can see the amount of work that is currently being thrown at the storage system is up to here. So this is the current operating point. And you can see on the graph higher up is the optimal point. So in this example, the workload could actually send more work to the ONTAP system, and it would still be able to handle it within that acceptable latency period. But you'll see that as the amount of work that the system is doing goes up, it's going to reach an optimal point. The optimal point is where the system is doing as much work as possible within the acceptable latency period. But if you started sending more work to the system beyond the optimal point, then performance is going to degrade and the latency will not be acceptable. So while we're looking at this, you're maybe thinking, well, okay, how do I know what is the acceptable latency for a particular application? Also, other questions you need to ask about the workload are how much storage space is it going to require and what performance does it require? Not just in latency, also the throughput and the IOPS as well. And luckily, you'll find that for most major applications and workloads, the actual vendor is going to provide you with that information. So let's have a look at an example. And here, this is from the Microsoft website. And this is a page that gives you information about the required storage if you're running SharePoint server with a SQL database. So let's just scroll down a little bit here. And I'll go to estimate core storage and IOPS needs. And if I go down a little bit further here, you see it gives you information that helps you estimate how much storage space is going to be required. So it gives you a formula which takes into account how many documents you expect to have and what the average size of those documents is going to be. And you can use the formula to estimate the actual amount of space that is going to be required. You also need to know what the required performance is as well. So I'm just going to look for that information that I already saved where it is earlier. And you can see that the required value is 0.05 IOPS per gigabyte to around 0.2 IOPS per gigabyte with a top end of 0.5. Okay, so when you are going to be deploying a workload on ONTAP storage, typically you will be able to find this kind of information from the vendor. So going back to the slides again, let's just imagine that this example workload is a SQL database for SharePoint, like you just saw in that previous example. And right now, this is the current operating point, and the optimal point is up here. If we are using Performance Manager, we will get reports on the headroom that is available. And then let's say that the company hires a lot of extra users who are using that SharePoint server. We start throwing more work at the storage system, and we see that we're going to reach and then go past the optimal point. So for that situation, we would need to improve the performance that was available for that particular workload. If you do look in Performance Manager, it will give you suggestions in there for the best way to do that. And the kind of suggestions that you're going to see are shown on this slide here. So first up, ONTAP has a scale-out architecture. You can add controllers, disks, and shelves to improve the overall performance that is available on the cluster. Other hardware you can add flash cache and flash pool, the caching technologies that we covered in earlier lectures, again to improve the performance. You can add SSD drives, so you can use SSD drives rather than spinning disks. They've got better performance. You can add disks to an aggregate. When an aggregate is doing work, that work is spread across all the disks that make up that aggregate. So if you add more disks to it, that gives you more possible performance. And actually, you'll see that sometimes for some workloads, it's advised to make the aggregate bigger than is required for the actual amount of data that is required to be stored. The reason for doing that is to get those additional spindles for the better performance. Other things that you can do for a particular workload, if you find that you've got an aggregate which has got multiple volumes on there and there's not enough performance available for all those different volumes, you can move the volumes off to a different aggregate or a different node. You can also upgrade the ONTAP version. Every time that a new version of the ONTAP operating system comes out, NetApp have made further optimizations to improve the performance. So you will normally see a performance boost when you upgrade ONTAP. And the last thing that we can do is we can configure storage QoS. So with these, moving volumes to a different aggregate is going to improve the performance for that particular workload in the aggregate. Also, storage QoS is used to improve the performance for a particular workload. All the other things that you see here, which are done at the hardware level, they are going to typically improve the performance overall on the cluster. Also, upgrading ONTAP will do that as well. Okay, so one last thing that I want to show you here. I want to just give you some ballpark latency metrics for the different types of disks that you can use. So in this example, we have got a client which is on the same local area network as the NetApp storage system. So the latency from the client to the storage system is going to be around about 1 millisecond. Then this is for read requests. If the read is served from system memory, that is fastest. That's going to be up to about 0.1 milliseconds. If it is served from flash cache, that will be up to about 1 millisecond. The same for an SSD aggregate as well, because they're using the same type of technology. It will also be up to about 1 millisecond. If the read is served from a flash pool aggregate, then that will be from 1 to 7 milliseconds. The big gap there is because if it's served from the SSD cache, it will be up to about 1 millisecond. If it's served from a SAS aggregate, the actual spinning disks, it will be up to about 7 milliseconds. If the read is served from a SAS aggregate, you're looking at around up to 7 to 11 milliseconds. And if it's SATA, up to around 15 or 18 milliseconds. So you can see there that the actual hardware that the read is served from is going to have a big effect on the latency. Thanks for watching. If you want to get hands-on practice with NetApp storage for free on your laptop, then you can download my free ebook, which you can see above my head right now. Also check out my NetApp Storage Complete course, which will teach you everything you could possibly want to know about ONTAP. Thanks.